Assalamualaikum warahmatullahi taala wabarakatuh. Today we will continue our class on artificial intelligence applications in power system. So basically, since we have something come up, so this week our class will be asynchronous. So I will record this video, okay, and then I try to make a three parts of the video. So later we will discuss in details. So we will learn about the genetic algorithms, and then we look at the example of uh, previous questions about the genetic algorithm, and finally how we want to use MATLAB to solve the optimization problem, especially in economy dispatch. Okay. So basically, genetic algorithm is one of the meta heuristic uh, based on the evolutionary algorithms. Okay, we can say that is evolutionary algorithms because when we talk about the evolutionary algorithm, meaning that we have a population, then we go for the process of mating and producing the child or producing offsprings, and evaluate the new child whether the results or the performance is better from the parents. Okay, so we have discussed this thing before. So the genetic algorithm, we have two genetic algorithms. We can say that we have two categories. Number one is binary genetic algorithm. Okay, so basically GA allows, when we say about genetic algorithm, basically people will refer to the binary genetic algorithm. So when they have a different types of the genetic algorithms, normally they will spell out like continuous GA or real coded genetic algorithms. Okay, continuous GA, CGA, or real coded genetic algorithms, RCGA. So basically, this is quite similar. They use floating numbers. Okay, floating numbers. So when we have binary, we use binary numbers as the representation. Okay. So this technique initially developed by Holland and company, and then proceed by his students, Goldberg and so on and so forth. And then normally can be applied using binary or continuous approaches. So this is the analogy. Okay, the analogy, if we use the binary coding, so basically we call it chromosome. Each representation is a chromosome. So let's say we have 101101. This is how many bits? 1, 2, 3, 4, 5, 6, 6 bits representing the solution, candidate for solution. Okay, and then this is the evaluation process, meaning that you need to decode this binary into the real number or real representation to evaluate, and then after that we can get the initial results. So after that we need to use selection operator. Normally we use for mating, meaning that we choose from this population which uh, chromosome or which parents to be selected to be made and produce a new child, that we call it offspring. And then when we have this example 010 001 011 010 is selected for mating, and then let's say we have 1 point crossover, meaning that part of the bits is uh, crossover within between them. So we have two new offspring or new results. Okay, and then certain iteration or certain probability we can use mutations. So basically for GA we have we start with the initialize, and then we go for evaluation, then we go for selection of parents, and then we go for crossover, And normally crossover, the probability to do the crossover about 90% of the each iteration or each selection, and 5 to 10% will go for the mutation. So we can say that crossover is the exploitation, mutation is exploration. Okay, and then we go for evaluation, and then you have sorting process, meaning that the best is located at the top of the populations. Okay, so this is the flow that I have set it just now. Okay, normally GA begins with defining a chromosome or an array for variable values to be optimized. So if the chromosome has n var, meaning that you have the chromosome, we have P1, P2, P3 until n var. So when we want to relate with the power system or economic dispatch problem, so you have several power generation P1, P2, P3 until Pn. Okay, so this is the dimension. So sometimes they call it dimension or number of variables. So this is our chromosome or candidate for solution. And normally we will operate it within the population. So your population, let's say you have 4 generators to be optimized, meaning that you have 4 NVAR, and then normally you have population, let's say we have 20 populations times NVAR. So meaning that your population is 20 times NVAR. Okay, that's the initial population. This one is just example. They want to do evaluation. So the problem is with GA that is it requires for encode and decode. Okay, since the variable value is represented in binary, so meaning that you must do some conversion to go to get the real value. So that's one of the problem of GA lah. Okay, you have encode and decode. So this is an example lah. But there will be the problem of quantization because you samples the result. So when you do the extra bits, it's much better, but it's very long. Very long. You have a very long representation. Okay, representation. Let's say one generator P1, you use 4 bits. So you have 4 bits here, 0100, let's say, and then you have P2 0100 1100 1010. So you have 1 2 3 4 16 4 by 4 16 bits for to solve the results of the economic dispatch. 16 bits. So if that one, if you use 4 bits, so how about if you use 8 bits? So become very messy. Okay, this is quantization. So this one is an example. Let's say you have two. This one is the example that in the slide regarding to find the longitude and latitude. So you have x and y here. So later I will show you how we want to solve the GA by using to solve the economic dispatch by using GA example in the examination and test. Okay, this is the coding. So meaning that these values 11000011, you need to somehow to translate into the longitude or latitude. So this one, let's say you have into matrix coordinate 99, 25, or in terms of longitude, in terms of these values. So this is the difference between the GA with other with other meta-heuristic algorithms. Okay. Next, we move to the selection. So normally, and in my experience also, I use roulette wheel. So the probability to be selected. So you can use many technique. You can use this one is roulette wheel rank squared, and you can use tournament. You need for random, or you can use random selection. But as far as I'm concerned, when I'm doing my PhD in genetic algorithm applications, I use a roulette wheel. Okay, this is, and then we move to the operator of the genetic algorithms. Number one is crossover. So let's say we have this value, these two parents. Okay, these two parents, meaning that you have, this is one chromosome and this one is one chromosome, call it parents. Let's say we have 1 point crossover at this point. So meaning that these two will go to these parents that produce new offspring like this. And then these two will go for this parent that produce new offspring. So you let's say we have 20 population initial. So when you do the each chromosome, we go for the crossover method, or you go for the crossover operator. Now your population become 40, 20 times 2, because you produce two offsprings. Okay, this is example for 1 point crossover, and then you have 2 point crossover in these two only. We'll swap to get a new offspring. Okay, this is one technique. So this is the example. You have parent number one, parent number two. Let's say this one is the population, right? So they have a parent number one, parent number two, and then they will have crossover offspring number one, offspring number two. So it will expand the matrix double. Okay, so then you need to evaluate everything, and then you do the sorting process. So this one is an example, pairing and mating, which chromosome happen, family, and then you got offspring. Okay, Pama, Ma, Pa. Pama, Pa is a parents or dad or papa. Ma is mother. Okay, and then sometime when we keep doing the crossover for each iteration, it will stop and no new improvement have been occurred. So that's why we introduce mutation. Mutation meaning that this is, and the other name of crossover, or the another interpretation of crossover is, we call it exploitation, and another interpretation of mutation is exploration. We want to need to explore a new results. So let's say we have a new at a certain probability. Let's say you have for a certain 5% of the running of the iteration, when the probability is need to do the mutation, so you do the mutate of this. Let's say this chromosome is selected, from 0 it changed to 1. Okay, so this one is population after mating and then after mutation. Sometimes can give the big good results, sometimes make it worse. Okay, okay, that is a binary genetic algorithm. So next, what happened is we have continuous. Continuous genetic algorithm is similar with the binary, but the crossover, the problem is what happened in the crossover, but it's quite simpler when we use the continuous representation, meaning we use the floating numbers normally. Okay, the rest is simple, similar, but only the representation is different. Okay, so this is the algorithm flows. We define the cost function, we generate initial population, find the cost of each chromosome, we select mating for reproduction, we do the mating, mutation, and then convergence check. So repeat again. Okay, when we compare by the binary, there is no step. No. This one is if you use direct representation. But normally I will use a real coded, which is we have encode the result in terms of the how to get the solution. So let's say we have this one example, and how we want the problem for the continuous GA is how we want to do the crossover. When we do the binary, we know that the bits will be swapped. But how about the continuous? I think still need the encoding. This is quite we still need encoding, because not encoding to binary, but it's continuing encoding to the continuous value. Normally use floating points. So this is the step we set up similar, but now your population, we call it population in terms of random number between 0 to 1. Say they say you have 0 0.5, 0 0.1, 0 0.75, 0.9. Previously, we used binary, meaning that you have very lot bit numbers, right? So when we do the continuous GA, so we just only have the floating numbers, representation of the results. So I show you later when we discuss about the example when we want to calculate the when we do the encoding or decoding. Okay, similar we have env. This one env meaning that we have four variables or with four generators to be optimized, and all variables are normalized between 0 to 1, and then you need to denormalize, and then you do the initialization C1 random and port n1, meaning that this is number of population, this is the number of generators. Okay, and then this one you can use many techniques. So this is one of the techniques you can use. Pi 20, PLO 2020, your pnom 0.75. Let's say you have, when you do the coding number, random number 0.75, you have the minimum value. If high value is 20, the minimum value is minus 20. So maximum minus minimum times this value plus minimum. Okay, normally like that. Okay, so let's say you have 0.75. So let's say this one in terms of general example, let's say we have our PG1, it must be operated between 10 to 100, right? So how we want to find is 0.75. So this is 100 minus 10 plus 10, right? So this is the P norm, this is max, minimum plus minimum. So you get this 90 times 0.75 times 90 plus 10. So how much you get? So you get the value about 0.75 times 90 plus 10. So you get 77.5 megawatts. Okay, this is the example. And then we do the natural selection. You can use the rank chromosome, or you can use similar with the binary. You can use roulette wheel and so on and so forth. Or this one is pairing methods, autonomous methods. This one pairing, or you can use weighted random pairing, or you can use tournament. Okay, so depend. And then mating or crossover, you just swap variables similar with the binary, you just swap, or normally that one is not, will be given bad results. Based on my experience, normally they want to give the knowledge new, there is no knowledge, because you just, the real value is not so much uh, influence the results. So normally we blend, we can use the blend method. We combine values of parent into new values like this. Okay, so when we use the crossover, simple crossover, meaning that we just swap. So this is the problem. Let's say we have parent one, parent two. You have uh, M represent for mom, D represent for dad. So you have M1, M2, M3, M4 until M number of variables. This one is dad. When we do the offspring number one, let's say we have here, we just exchange the value, exchange the uh, mom and dad into the to get the new offsprings. But basically, it's merely is interchanging data, no new genetic material generated. So that's why we use this one. We call it blending method. This is what I do. This is what I did when I do my PhD. Okay, so just this a random number, one plus minus 1 minus random number between 0.1 times PDN. PDN is the dead nth variable of that chromosome. PMN is the mom chromosome times beta. Okay, so this one variable will be blend. So you can use different variables beta for each one. So this one is depend. You need to try based on your problems. Okay. So when we use blending method, it work well. So this is a book from Michael Weeks, 1994. The book is colored in yellow. Last time when I'm doing my PhD, this book is one of my reference, main reference. Okay, but the problem values are bracketed by the extreme they represent this population must use extrapolation. So another things we can use extrapolation. Okay, this one is extrapolation methods. So extrapolation into the value outside range of parents. So we have, let's say we have linear crossover. This one is 0.5. This one 1.5 minus 0.5. So this one average. This one lower higher. This one higher lower. Okay. So as I mentioned again, this is based on you need to test to your problem. Okay, when we do the genetic algorithm, we can use many approach. We can use binary, we can use continuous, and then we can use extrapolation. We can use blend or any other methods, any other techniques that give you the best results. Okay, so this is what we have done if you use the extrapolation method. And okay, my PhD basically I'm using extrapolation plus crossover. This one is you can find in Haupt book, Practical Genetic Algorithm. Okay, book that has been written by Haupt. So normally I'm using extrapolation and you plus the crossover. The crossover point alpha, you round up the random number times number of variables, and then select the variables for crossover. We select using normally I'm using roulette wheel. Okay, and then this is our parents, and then this is mom, this is dad. So we just want to find the p new. We just use these equations. we we use extrapolation and crossover. So we have p new based on these equations, and p new 2 based on this equation. So you have p m mom of the alpha minus beta. So of course the beta, alpha and beta is a random number. Alpha is a round up. So which variables need to choose? Okay, times beta. This one is selected. Let's say we have selected at m alpha and p d alpha. You just subtract. This one just similar subtract, but this one is minus. This one is plus. Okay, you get the two results. Okay, so you get this new offsprings. Okay, and then you swapped in offspring. So this is, as you can see here, you have offspring number one until this one p new, and then the rest is that's properties, or that's this one is PD, right? The upper one is PM. So option number one starting from PM, and then this is a new that you operated just now, and then the rest is the dead, and then you swap. So meaning that you use extrapolation and crossover. This one is mom. Okay. So you can use many approach that suit your problems. Next, for mutation, simple. Normally, you just create a random number and times which uh, which variable needs to be multiplied. Okay, so this is the can be can introduce novelty, new things, can be avoid early convergence to local minima, and then when you have a higher mutation rate, your exploration will be bigger, but your convergence will be slower. But normally I set not more than 10% for the mutation. Okay. So this is the elitism when one of the components or one of the characteristic of GA that sometimes people discuss in details the elitism, but for my experience, I just ignore it. Normally, when you do the GA, it's always keep the best chromosome because we have this sorting process. So the best results will be located at the top of the matrix. Okay. So this is the next generation. Similarly, we just calculate again, and then until the next iteration, until the iteration is maximum. Okay. Okay. I think that is for this section. So later we try to solve ED using GA, First, I think I want to discuss how we, for example, I use example for the test or the previous final exam in order to for you to get the idea how we do this solution using GA. And later for the third section, we try to use MATLAB to solve a GA, to create a GA coding to solve the economic dispatch problem. Okay, I think that's all for this section. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.